Today, I'll be talking about our project, User Study of a Virtual Reality-Based Chip Testing Training System. Here are our members. So, chip manufacturing and testing is a highly specialized field that requires expensive equipment, strict safety protocols, and precise environment conditions. This results in a gap of not enough training for workers. To address this gap, a laboratory developed a VR-based virtual training system for chip testing, and this study was authorized by the lab to use their training system.
So here you can see our current training challenges. The main issues we have are the high costs, safety concerns, and the strict working environment of chip manufacturing testing.
About related work. First part, VR-based education. Its extensive learning outcomes create safe training environments, minimizing risks, improve learners' understanding of abstract mathematical concepts, make complex and invisible process more tangible.
The second part is the VR-based training. It engaged to understand the steps without the need for physical materials or specialized equipment. And also, it enables learners to gain familiarity with tools and techniques. And also, it enhanced learners' spatial awareness and procedural memory.
And the following is our methodology. We use Unreal Engine 5.2 as our software to enhance the training realism and safety. The HTC Vive headset and Fusion motion capture gloves as our hardwares. These will be going to ensure that VR can mimic the real labs and we can accurately replicate the chip manufacturing process. Finally, we have gathered the feedbacks based on the system and we will improve our work to find innovations in the future.
And VR mimics the real lab with a ratio of 1:1. Some examples are the control panel, 9-hole platform, and vacuum chamber.
Okay, so here's a brief overview of the VR equipment. And here's the software control and interactions with the equipment in the VR training system.
About the actions we took includes visiting the chips lab. We communicate both hardware and software with them, and then we collect data. And lastly, we analyze the data. We conduct pre-test, post-test, and motivation survey.
Findings. First picture is about the participating in the VRChip training system increase learners' understanding of the chip manufacturing process. And the second pictures is about the participating in the VRChip training system increased learners' motivation to study chip manufacturing.
And discussion. So our current VRChip system needs a professional to give guidance, and this can be fixed by integrating an AI into the system. And secondly is we can improve our system into an AR, which is better operation in both virtual environment and real lab equipment. And finally, we can switch our software into Blender and Unity for making models and animation.
Yep, here is our future plan. We hope to integrate AI into VR training system, which our team leader has experience doing before. And this can greatly improve the user's learning experience as they can get assistance from the AI during the learning process. And then we switched our hardware into MetaQuest 3. It both has AR and VR capabilities, which can track hands and make an immersive vibe at the same time. So there's no need for fusing motion capture gloves. And lastly, this way more portable, we also plan to switch to Unity as our software. This is the software that's taught in our STEAM class. So we have the more experience with it, and we believe that we can improve the future training system.
Here's a short video showing the VR environment, our visit to the laboratory, and also our data. Here are some references, and thank you for listening.